speakers, Dr. Stephen Crawford. Not worried. I know we are 15 minutes late, but the coffee break will be preserved. It will not.
Yeah, this is mostly an advertisement, so I'll definitely catch up on time. I'm from the Joint School of Nanoscience and Nanoengineering in Greensboro, North Carolina. The reason I am here advertising ourselves is because we are partners with IEN at Georgia Tech. We work with the clean room as well as the MCF facility. Basically, it's part of SCENIC, which is itself part of the NNCI, National Nanotechnology Coordinated Infrastructure. That is the NSF-funded program that helps Georgia Tech or IEN as well as ourselves do a lot of the things we're able to do with our core facilities. SCENIC is the name of our site, and our site is actually two sites, Greensboro and Atlanta, of course. But that is the delineation. And to make things even more complicated, JSNN itself, if you haven't heard of it, is a partnership of UNCG, University of North Carolina, Greensboro, and North Carolina A&T State University. They're both UNC system schools, but because the UNC system is so old, they are literally right next to each other. Almost 100 years ago, A&T was the historically Black college, UNCG was the women's college. Now, of course, everything is integrated, so we have two slightly different universities right next door. And JSNN itself is a satellite campus that is the nanoschool, just like it sounds, but it is a cooperative effort of the two universities. And we have faculty, students, staff, such as myself, who basically belong to both. It's an odd situation. The facilities at all NNCI sites in general are used for lots of different things, but there's definitely an emphasis on nanoscale lithography and related characterization and analysis. So top-down lithography and bottom-up nanofabrication, as the case may be at different sites. Nanoscale characterization, imaging, and metrology, which is the majority of what we're focusing on at this workshop anyway. Trend for materials, processes to complex devices, systems, and their applications. At our site, we mostly do unit process. We don't do a lot of device creation like they would do here in this clean room. There's lots of different disciplines, as you can imagine. It's definitely that way at Georgia Tech as well as our site. Nanomaterials, nanoelectronics, MEMS, sensors, life sciences, earth sciences, as we just saw. Lots and lots of different people doing lots of different things. Also, as part of this initiative, SCENIC and NNCI in general, there is a focus not just on research, but also education, training, workforce development, and outreach, which the folks here could definitely tell you more about if you're interested. SCENIC itself, like I said, is just a partnership between IEN at Georgia Tech and JSNN, where I'm from. Two very similar looking buildings, but I promise you we are 5.5 hours apart. If you want to head to JSNN where I am, just get on 85 and drive until you're about to fall asleep. We're 334 miles straight up 85, real easy to get there, it just takes a while. So between the two sites, or between SCENIC sites, we're essentially one facility at two different locations, and we try to cover the majority of the Southeast. The reason why NSF funded us and what we attempt to do is to service other academic institutions as well as businesses to make sure they have access to the resources they need to get research done. As many of you probably know, a lot of this equipment that people are looking at and talking about today is very, very expensive and very hard to get. We also have a Rigaku SmartLab coming to our facility I'll talk about here shortly, and it took us 4 years to finally get one ordered. So a lot of smaller entities just don't have the opportunity to order everything they need. So sites like ours help you connect to the resources required to get your work done. The SCENIC resources in general cover the IEN micro nanofabrication facility, materials characterization facility, MCF, JSNN clean rooms, analytical, material testing, biology, and computational modeling labs. There's about 300 installed fabrication and characterization tools last time we counted, and about 40 technical staff members between the two sites. So JSNN specifically, I'm going to go very quickly through the things that aren't analytical characterization, because I know that's what you're most interested in. Top-down fabrication tool that's very similar to the clean room here, only much smaller. We have a smaller user base and smaller faculty. Clean room is a relatively small part of what we do. Advanced microscopy core is significantly larger for us relative to our clean room. We have helium ion microscope, a number of SCMs now, environmental and FE, scanning probe microscope, and a number of optical microscopes that I couldn't possibly list here. That is the majority of what folks come to us outside looking for, is just good old-fashioned microscopy, looking at what whatever they've made, especially with industry. We have the Gateway Material Testing Center, which I won't get into too much now because that just complicates things even more, but just know that we do bulk testing as well, material testing for aerospace industry in particular, just breaking things. We have chunks of Kevlar that we have to determine, are they going to be bulletproof? Well, we don't take it out back and shoot it with a gun first. We actually put it on a testing rig, and we do that on site as well. Soft matter nanobiology core at JSNN, just like it sounds, it's pretty traditional biology and genomics labs, the number of faculty there. Computation modeling core, we actually just got another new supercomputer back in the spring that I'm still trying to get fully connected. And we have a advanced visualization center that was mostly made obsolete by AR and VR, but we are replacing that soon. There's a lot of computational and modeling work done at JSNN. All right, so we're into the meat of it. Analytical chemistry core at JSNN encompasses many different things. We have a 400, 700 NMR that are very, very popular. The 700 in particular is basically occupied around the clock. Various types of chromatography, XRD, which we're all here to learn about this workshop. CT is a recent addition. Confocal Raman microscopy is something that is very heavily emphasized by our current faculty. Various types of spectrometry and some other things that we'll talk about. We added a Nikon CT last year, about a year ago now. It was installed. It is X-ray. It is a bit of a different source from XRD system. This grant that was awarded was mostly to look at museum specimens, though significantly larger than what we typically work with. In our other work, we are a nano school, and those skeletons are decidedly not nano. Just to give you an idea, the stage for this system isn't this big. It holds samples that are up to 50 kilograms in weight, so completely different beast. But we are doing a lot of different work with that, with our new micro CT. XRD, so this is what we have on order. Ours are not installed yet. They're not in the US yet. We expect to have it, last I heard, from our friends at Rigaku sometime late February. We hope to have this installed and ready for you all, for users, within the semester itself. Our setup is very similar but different from what you'll find here at Georgia Tech. You can certainly talk to David, and he can give you a little bit better rundown of what exactly is different between ours versus the two that he's got downstairs. We are using the standard copper tube for ours, crossbeam optics, the 2 and the 4 bounce monochromator, in-plane diffraction. We do have an auto sampler for ours, which I'm very happy about. We have a number of different sample holders, but that includes the airtight sample holders like some of the others mentioned today. There's a lot of battery research going on, and we have a basically a new battery lithium spinoff company at UNCG who made sure that we have everything we need to do battery research on our system. We do have 2D Sax wax with the grazing incidence Sax wax accessory on there, as well as the same Reactor X high temp reaction chamber as they have downstairs here. So there's definitely some duplication. The hope is, if our system goes down for service or theirs goes down for service, as happens with every tool, we can hopefully back each other up a little bit. We did get the HiPix 3000 2D detector, as well as the micro area measurement package with the various precision stages and motors. I don't know as much as I would like to about our system because I haven't seen it yet. What I do know, it's mostly been taught to me by Keisuke by Zoom last year, so thank you. Be learning more about that here shortly. In addition to that, we also do have currently single crystal XRD up there at the top. That is an older Gemini system with an Atlas detector, definitely a legacy tool. A lot of the work that's being done currently at JSNN is single crystal metalloprotein work, just because that's what we have access to. We've been going to other sites. Powder, this is actually going to be our first powder or thin film XRD. Chromatography, we got a number of new additions this spring. I am the equipment manager, if I haven't already said that. So it's my job to do the installations and set up for everything that comes into the building. And we got about $5 million worth of equipment back in the spring, and that's been my entire 2022 was just getting things installed. We have a new GCMS and a new UPLC that have been brought in. There was some mention earlier about the need for speciation of certain elements. I did a lot of gallium arsenide work myself during my PhD at JSNN, and we used a similar setup. We also have a new ICMS to basically do the speciation for arsenic, because it's important what the species is, not just how much arsenic is in the water from a cleaner process, basically. Anyway, we also have a brand new UV Vis spectrometer with integrating sphere and the UMS, Universal Measurement Spectrometer. Various fluorometers, FTIR, the usual bread and butter kind of stuff. Elemental analysis, we also added a brand new ICP-MS a few months ago, Agilent 7900. This one we got largely to do some high throughput work that we've been working on for a while in our OES, as well as single nanoparticle analysis, which is very important at Nano School. A lot of our faculty do, synthetic chemistry, synthetic nanomaterials. So the single particle analysis is very, very nice in a tool like that. And we do have microwave digester on hand. That one is, again, something we do a lot of work with outside entities, academic and industry. Some people don't really care about ICP. They just want to know what's in this. This is what usually tells us. We also have the Thermoscientific ESCO lab, which is very similar to the K-alpha and the coming Nexa downstairs here. That gives us XPS, UPS, ISS, and reels, as well as monatomic and gas cluster etching for depth profile. Again, I won't get into all that because we don't have time, but basically this helps us, this whole page, with when you have something, you just don't know what's in it. Sometimes we are mad scientists without meaning to. This tells us what's in something so we can move forward with other techniques. All right, microscope-based spectrometry, we have a lot of that now as well. We recently purchased a Thermoscientific IS-50 with the Raptor microscope and ATR. That is a brand new system. We actually had to wait for someone in the US to learn how to use the microscope before they would train us last month. That does automated imaging as well as auto ID of any samples put on it. We have a Hariba Explorer confocal Raman, as well as a brand new VTech confocal Raman that we also added recently, with dual spectrometers, 3 lasers, and a piezo stage. A lot of money put into that recently again, as well as Cytoviva system and Olympus LSM, which are typically more biologically oriented, but we've had a lot of materials folks using those recently. Cytoviva, if you haven't heard of it, is very useful for imaging nanoparticles, nanomaterials with an optical scope. It uses some tricks to make small nanoparticles appear even using optical techniques. I used it during my for my dissertation, looking at 20 nanometer silica particles. So it's handy just to be able to see these things. Particle analysis, we've got a, again, brand new BET that's getting installed probably week after next. Malvern Zeta Sizer, Nanosite particle tracker, again, pretty standard stuff if you work with nanoparticles. TGA, DSC, DMA, and thermal conductivity round us out for the various thermal needs that we've got. And for interfaces, we have some rheology that's being done on site. It's fairly new. Force tensiometer, as well as a Ramey-Hart goniometer tensiometer as well. It is a very, very full lab now. So SCENIC user support, how do you actually get access to any of this stuff? It's very similar to here. If you work with IEN, MCF, you're pretty familiar with it. Of course, you don't go through their administration, you would go through ours, but we do talk to one another and we make that as simple as possible. But like here, you can do the work yourself. We'll train you how to use any of the things I just mentioned. We can do the work for you. You can just send us samples if you're interested in the science. Most of you probably are. Great. You've got a friend in industry who does not care. They just need a data point. Great, we'll do that as well. We'll do collaborative research with you if you would like, or just get you the data. Sponsored research, special projects, all sorts of things. We're all very flexible. There's a lot of support for non-traditional areas. Don't think that if we're not interested in your particular research, we will turn you away. We don't do that. I know some sites do. They just have to be in it to really be willing to move forward. All of our folks are pretty open, our faculty are very friendly. Advanced training modules are offered primarily IEN, but we do some of that at JSNN, like the short courses and things like that. And SCENIC Catalyst and IENC grants do exist. So if you are from an academic institution that is not Georgia Tech or JSNN, and you would like to come up to us and use some of our equipment, or here at Georgia Tech as well, but you just don't have the grant money together yet, definitely reach out to us, and there are seed grants available to make sure you're able to, get some data to put in for that application. All right, so that was a very quick rundown on JSNN. If you are interested in who we are, what we do, certainly go to our site, which is a very long URL. You can just, Google JSNN, first thing that pops up every time. You can email me, s_crawford@unc.edu, or the person who would normally be standing here, Sham Arvamuddin, who is our director for facilities as well as JCERT and SCENIC. You can email him as well. One of us will be happy to get you any answers that you need. If you can't remember this or just have written it down or anything else, definitely reach out to the folks here and they can put you in contact with any of us. We talk to each other all the time. Thank you.
Anyone have any questions? So I've got one.
Yeah.
And this is the thing I always wonder when I look at institutions like ours. How do you determine what you should get next or what you should replace next? What is that? What is that process, or is it sort of like trial by fire? We should fix this now or get this now.
It varies a lot. Our faculty or our setup is different from here. So our core facilities are basically embedded within a department rather than being separated from it. So the faculty definitely have first say so, which I know that there's some similarity here. So if the faculty are just begging the dean for something, then of course that's first thing on the list. We do record any requests that we can't fill. We have to send somebody to Chapel Hill for a particular technique, and then we're doing the same thing month after month. We know, okay, clearly we need one of these. Or if we just can't find anybody who's providing that service within the area, then that goes on the list. What it really comes down to, and when it came down to this spring, when we had a very large check of money and a lot of equipment we needed to buy, was what can we get? We had a list ready when that money came in, and the problem with being a state school, especially in North Carolina, is whenever we try to spend money, we have to have it spent within the fiscal year. So anybody who could not deliver us what we needed by July 1st of 2022, they were automatically off the list. So in the time of, supply chain constraints and recovering from COVID, that was a very real thing that we had to worry about. So it's a combination of factors. What can we get in a reasonable timeline? Because we had folks telling us 2 years for certain goals. As well as what are people asking for internally, what are people asking for externally, and then I'm the lone voice in the building to also remind people, what do we actually have room for? Because square footage is tough everywhere you go, especially in academia, and it's certainly tough with us. Yeah, we could get your giant ICP-MS downstairs. There's folks where we are, the isotopic one, who would love that, but they would never think about where we're actually going to put it. Sometimes you have to build new labs. All right.
Thank you very much.
Thanks.